kits. So we are the subsidiary of our mother company ETO. Our mother company is integrator, you know, manufacturing commercial fiber laser cutters, and we Skyfire um, sell laser kits, laser parts, and do all the laser service around the lasers, such as retrofitting, upgrade power, and repairing, fiber laser source repairing, and
Do you have
I would
y'all hear
say
that
we,
echo?
yeah, all around that. Mm. And as for this contest, this is our first DIY contest. So for those who have already bought our laser kits, they DIY their machine, and after they finish it, they can shoot a video explaining how they did it, and we can adjudge and allocate all of them as a participant, and select top three and give some cash vouchers as awards.
Gotcha.
Mm-hmm.
I have a huge echo when y'all are talking, so I don't know if it's on my end
Your
or
echo? Okay, let me
actually it's
try to
better
fix it.
now.
Hold on. Extremely severe echo.
Yeah, it just repeats every word you say, basically.
Okay.
I don't know if it's on your end or my end.
My side is perfect. Let
Okay.
me let me try to fix it.
Yeah, when I started it, it's fine, but now huge
Mm,
echo.
I think at your side you can try to wear a earphone, and you can re-enter this room and select I am wearing a headphone or something.
Yeah, I might do that.
Okay.
Give me a second. Can you hear me now?
Yes. Even better. Mm-hmm. What about the echoes?
That's really bad
Still?
still.
Still? Oh. Hmm.
Let me leave and come back. Is that okay?
My side is always good.
Okay. Let me
Mm-hmm.
leave here.
Yes, waiting for you. Great.那么你在那个哦，你在准备是吧？Okay, Craig is coming. Hi, Craig. Hi, Craig. See you
Hey,
again.
hi. Hi, nice to see you.
See you again. Hmm. Uh, Kyle just ended in, but he was experiencing severe echoes. So now
Okay,
he's trying to fix that and re-entry. Then we can
okay.
start.
Let me, got multiple tabs open. Let me close some of these other ones. It's complaining over here.
Mm-hmm. So how is the sound at your side?
Oh, your sound is great. Yeah, you sound
Is
good.
there any echoes?
No, I don't hear any echoes.
Okay. Kyle.
Yep. Do you hear me?
Mm-hmm. Yeah, perfect.
Yeah.
Any echoes?
Not anymore. I think I had two windows open and I didn't know it.
Okay.
So it was on my end.
Okay. Okay. I think we can start it. Actually, it has already started. So
Yeah, I have.
let me introduce myself and the lady beside me. I am Xiaodong, the marketing manager of Skyfire Laser, and this is Emily, the sales manager of Skyfire Laser. And this is our podcast, Laser Inside China. And today we're going to discuss about a hot project turning into a handheld fiber laser welder into a CNC laser cutter. I am joined by two innovators. The left in my window is K-Rigg. His YouTube account is K-Rigg. So has hardcore content packed with real THC experiment and usable data. And the right side in my window is Craig Halbor, a true DIY spirit from our first DIY laser contest, who integrated also a fiber laser welder into a Crossfire Pro with a smart safety and control mouse. So you both attacked the same challenge from different angles, but by comparing where you overlap and where you differ, I hope we can truly demystify this hack for everyone watching. Okay, so um, I think it's I feel very honored to have both of you. Actually, this is my first remote online podcast with two foreigners, so I feel excited and also a bit of nervous. I want to go with first go with Craig. Craig, at 12:50 in your video, I'm gonna share this video right now.
Okay. Good morning over there in China.
Okay, okay. Hold on. Screen. Okay. Okay, you guys can see it?
Yes.
Mm-hmm.
Okay. At 12:50.
Right.
Hold on. Yeah. Here. I'm gonna pause it. And my question is that you called out the 125 psi for 3 mm aluminum cutting, right? And does
Correct.
that mean you actually implemented gas pressure control?
No.
Is it? Oh,
No,
okay.
the 125 psi is the maximum that we can get out of our shop
Okay.
air compressor.
Okay.
Okay,
And
we'd like to go a little bit more, but we're just that's the highest we can get our compressor to go.
okay. That's just my a little confusion. So I'm gonna confirm
fine.
with you. Yeah. And I've go through your video. I like all the optimization designs you have done for this project. I love your safety chain, the foot pedal, where the laser only fires where your foot is down, and
Yeah.
the 3D printed clamp for quickly mounting the laser head onto the Z-axis,
Right.
and your external fiber support bracket for keep the bands under control. Yes, to protect the fiber cables, and all that you did is impressive. And
Well, thank you.
now I want you I would like you to explain to all the audience about your project, and yeah, you guys can discuss it. Yeah.
Okay. Yeah. So for those of you who haven't watched my video,
Mhm.
I've had a Langmuir Systems Crossfire Pro CNC plasma table for about 5 years, and it's a very reliable machine. It really works well, and we've been watching, like a lot of people, all these very attractive laser welders and laser cutting systems. Recently, all the shorts and things on TikTok and YouTube and Instagram. So we decided we had enough. We had the funds. We've got the funds together to go ahead and buy one. We wanted to try it out, and we got it. And it works really well. So we decided to see if we could actually just put the laser head, which you've seen here, is mounted on our plasma table, and have the control system in the plasma table basically pull the trigger on the gun. And
So,
that's what we did. But there is a safety system built into these to keep the laser from being live and to control it when it's in a safe position. So we just implemented a foot switch. So you have to have your foot on the switch in order for the laser to turn on. And then it, if there's any problem, you take your foot off and it turns the laser off right away.
Craig, how about this? I stop sharing your video. You share it, and you demonstrate your project with the.
Oh, okay. Hold
Okay.
on. Let me bring up that video. I guess I should have had that queued up, huh? Yeah, just a second here. So some things that we did. So what you're seeing on the screen, oops.
Not yet.
Let me share it here. I think it's this one. Share my
screen.
Share my screen. Hold on just a second. I gotta do a little rigmarole over here. Okay, you can see this now?
Yeah.
Okay, so what you were some things you were talking about are the gun that my business partner got a 3D step file of we have our lasers equipped with a SUP 25T laser head. We got a step file for that, and he custom printed this holster that easily comes off with a thumb screw, and it enables us to easily pull this off, and we can switch from being a welder to a laser cutter in about 30 seconds. And then the things you were talking about to protect the fiber, there's a minimum bend radius on the fiber. See if I can figure out where that is. It's over here. So at the top of the bar where the normally plasma torch goes around, plasma torch is a little bit more forgiving. You want to protect the fiber from too tight of a bend. So we 3D printed this fixture at the top, and it's got a trough on it to hold the fiber bundle in at the top. And then as it goes down, we also fabricated some like little U clamps that kind of make a trough for the fiber to go down the backside of that. And this whole setup allows us to have enough slack to move all the way over the entire work area of the CNC plasma table, and it does not introduce any kind of tight curves on the fiber bundle.
Yes.
So we did that. We also did some other things. If you see over behind me.
Yeah. Magnetic 3D casted box for.
Yeah, we have. Yeah, I bought five pairs of safety glasses from Skyfire, and I didn't want them like in a drawer or anything. I wanted them easily accessible, so we just made some little boxes that had magnets in it, and they stick right onto the wire feeder. And then that gray one on the end is where we have our consumables, because when you switch between a fiber laser, when you switch between a laser cutter and a laser welder, you got to switch the tip out. So we have all of our consumables in the gray box. And also you'll see down on the machine itself, we have a 3D printed cover on top of the touch screen.
I still did not understand what is that cover for.
In case you drop something, you don't want it to drop onto a touch screen.
Okay.
Yeah. So we did that. So yeah, it's really functional. The whole thing, everything worked, and it was really simple for us to interface the two machines together. What we
Mhm.
do not have is torch height control.
Yeah,
Okay,
yeah,
so
but yeah, Kaya did it.
and
So I
I was
think
very interested in what Kyle did, and
okay.
I'll let him talk about what he did. But I
Okay.
found it fascinating. As soon as you posted this video, I went and watched his video, and
Yes,
it's
exactly.
very
I have
it's nearly something. It's exactly what we need as well.
yeah. So I go through both of videos. I think if you collaborate with each other, Craig, you did very optimization design for in the hardware, outer appearance, but Kale did it software and the control system. If you collaborate with each other, the the product would be better. And
Oh, no doubt, no
okay,
doubt.
mm-hmm. Let's go with Kyle's video, K-Rigg. And how about that, Craig?
Yeah, let me stop sharing.
Okay, so Kyle, you can share your screen.
Okay. Hold on.
It take your time. Take your time.
Okay. Can y'all see that now?
Yeah. See it.
So let's the laser I used wasn't one of y'all's lasers. I didn't really know about y'all until probably about a month ago.
It's okay. It's okay.
But basically, this part right here is where I was able to. Oh, that's a commercial.
It's okay. As
So basically, this is just like how I did it. I integrated into the system to basically
Kyle.
Kyle, you're breaking up.
Uh, I cannot hear a sound.
Yeah, you broke up.
Can you
there,
hear
Kyle.
me?
Yeah.
Now is good.
Sorry.
But
it might be when I'm trying to play the video, so I'll try to just kind of run through it. But let's get to the so originally I did basically the same thing as Craig did, which was just a simple mounting the head to the table and basically an on and off system. That was the first part of the project, and it worked great for small pieces, but needed something that I want to be able to cut a full sheet of material. So that's when I started to look into basically these torch height controls, and these are originally meant for oxyacetylene torches, where you have a flame torch where you can't, there's no torch height or there's no arc voltage like in a plasma cutter. So I was able to search the internet. It took me several days, but there's two companies I was able to find. This company is out of Vietnam, and there's another company that I haven't used theirs yet, but I bought this Capo 4 from the eBay basically, but I don't know where they're manufactured. But the neat thing about this is it basically takes the capacitance, which is the ring of this ring that the laser goes in, and that's how it senses the height of the material. And all it does then is give you basically relay inputs of either up or down signals that you can then in your control software for your CNC plasma table, you can basically swap out what your plasma was giving from an arc voltage to basically use these systems. So it's it's very dependent on what your control system's like, but a very generic control system has your breakout board, which takes all the signals from your computer and then splits out to the motors, and then your outputs to your on and off for your laser or plasma, and then it's taking inputs from other usually boards like a THC that is from a plasma perspective is taking the arc voltage. Well, this is taking the capacitance from the plate, and it's just giving me the same signal. So from an integration standpoint, it's pretty straightforward. I had to do some software side of things where I didn't want the Z height to raise up every time after it cut, because I realized that with laser cutting, you don't have as much of a kerf width, so you don't have as many tip ups. So it really sped up cutting process, because with plasma, my table would always pick up about an inch, go to the next cut, go down, sense the material, and then go from there. Where this is always sense the material. Now there is some, a bit. There's caution to that, because I have hit the laser head and with the tip up or things of that nature. But the neat thing I did is, and I actually have it right here. Can y'all see this on my screen? Or do I need to stop sharing?
Ceramic or plastic?
No, so
Sorry,
this
okay.
is actually just plastic.
Plastic. Okay.
Just a piece of aluminum and piece of plastic, and then this is the actual laser tip, and then this is just a little
sharing.
Okay, sorry.
That's all right. Just stop sharing. Yeah.
All right, y'all get it now?
Yeah.
So basically, this is just a replacement to the cutting nozzle that you have on the
Welder,
with the system. So this is all screwed in, and this is just acting as a basically an insulator. And the reason that's important is because when you have this ring that goes around here, when it gets close to an edge of material, that ring might start not sensing the material and dip just below enough, because I have this almost touching the material when it's cutting. And so this system that I've kind of devised is with this little clip, I'm able to clip on that ring. And so that capacitance sensor is also sensing this tip. So what that allows me to do is to get really close to the edge. And it's basically taking both systems to sense this and that, to keep the torch height control. And I try to just use this by itself, but it wasn't enough. It wasn't enough area, because capacitance always works off the area. That ring was enough, but this by itself wasn't enough. So, which makes it pretty neat, because I could just basically, my mount's just kind of like Greg's, where it just slips in and you got one little kind of screw that bolts it in. And this allows me to take the head out really quick. I take one bolt out for the wire feed, and then put one bolt on to mount the table. And within 30 seconds, I'm, cutting from where I had it set up for welding. So it's really nice to be able to switch back and forth. And for a small shop like me, that's the versatility of it is what really, just blows me away, where, I'm even thinking about getting rid of my TIG machine, because this laser welder, I've just been doing all sorts of cool stuff with it. And then with the laser cutting, the ability to get finer detail has allowed my setup and my fit ups just go to another level that I just never thought was in my grasp until these systems came out.
Right.
Okay. Kyle, can I ask you a few questions?
Yeah.
So first, congratulations for getting torch height control working. And how did you capture and feed the THC height signal into your controller? Is it a plasma style interface or something custom?
So a little background on my end. I used to own a CNC plasma table company that we manufactured tables and such. So I understood the kind of the intricacies of how all that system works. So a lot of these tables are manufactured with basic components that are similar. So I kind of knew what the control system needed from an input and output perspective. And then I was like, okay, how do I find, my way of kind of finding a solutions to everything is, I'm creative, but I'm lazy. Like I want to find the easiest solution out there. And so I was like, okay, what other system out there uses a torch height control, but isn't relying on the plasma. And so I'm like, well, I've seen these torch height controls on oxyacetylene and flame torches. So I then went down that road of like, okay, well, how do these integrate with a CNC table? And so that's how I kind of went down that road and realized, okay, maybe I can, that capacitance torch height control doesn't care what's in it, right? It's just using the ring. So I was like, well, why shouldn't it be able to use with a laser? So that's how I went down that road.
Okay. So another question: did you implement dynamic laser power control? Adjust the power. Some
No,
PWM. Okay.
not yet. I mean, I thought about it because it with the software I have, it shouldn't be a big deal. But where I have that, just like Greg, where I have my system, my power source is right by my computer, right by my table. And, I just go over there and just adjust it on the actual machine. And, I know with I guess proper laser systems, you're able to adjust the wattage when you're coming into like a corner or if you're doing holes and piercing and things of that nature. So I kind of kept that dumb where like for 10 gauge, I just do about 1500 watts. And then on the softer side, like on my pierces, because I don't want any of that reflection getting into the laser. I don't have any pierce delays. I just adjust my lead ins to as long as I possibly can. And I just let it go as soon as it turns it on. And so I try to modify the software where, I'm not worried about the laser power as much. Now I will turn the power down for like thinner materials, thicker materials, things of that nature. I kind of wanted to, do this as simple as possible too.
Yeah. Yes. So all the questions I asked just now because we went through your videos with my teams. Of course, Bruce, our technical director. So actually, the question is what he proposed, and I read it down because I am not a big tech guy. So
Okay.
I just So actually, but I know he explained it to me that these the aspects that we can upgrade the project what you have done, so you can make it better. Yes. And next question is that, so are you doing multi-stage piercing sequence or single steel shot?
I just it's one and go. Yeah, single.
Oh, okay.
And I've been able to do 2000. I have a 2000 watt machine. I don't know what Greg has.
Same. I have the same.
Yeah, the same.
But I mean, I've been able to do that. That's 1/2-inch stainless steel.
Okay.
That I've been able to cut. So, I mean, which is crazy because I don't think that's in the capability of that really machine.
Okay.
And you could see that, with the pierce, like I'm running that pierce as far as possibly can. So I know there's, in the proper machine, when you say double, I think that's what it means is it's kind of going on a lower wattage to remove maybe the scale of the material first, and then it's blowing through. Is that what that's kind of referring to? But I've just found that as long as I can blow, turn the part on as quick as possible, by the time it gets to the actual cut process, it's already through. And I haven't had any real issues with the lenses, protective lenses being affected by it. And the only issue I've had is because this is plastic and I hit something with the machine sometimes. Because I'm using a 1.2 diameter nozzle. And the reason I'm doing that is because the same thing with Greg with the shop air. I'm about 110 PSI. The smaller the nozzle, I found that I have less dross. I mean, I've been able to get it down. It's still a little bit, but not as much. So that the smaller nozzles I've found has helped because it's just increase the velocity of the air. But the problem with that is if I hit something, I don't have any room for error, and it blows out this nozzle from the laser just cutting through.
Yeah.
So I mean that's.
I
But
think
it doesn't hurt anything else.
yeah. I think Emily can write it down. So maybe after this podcast, we can send some nozzles or consumables to Kyle and Craig.
So let me add a couple points. Let me add a couple points to what you're saying.
Sure.
So on our side, we control the pierce process with the post. We generate a post out of Fusion or out of SheetCam, and if we're going to cut really large, thick material, we do like what Kyle said. We intentionally get off the surface of the material, which increases the laser dot, and we're able to do cleaning at that point, and then we slowly traverse downwards to the cut level that we're going to be at. And my partner was cutting 5/16 cold rolled steel, and it came out really. We run at 10 inches per minute, which is pretty slow, but we're able to get through that, and that worked pretty well. And so, how when you're with your torch height control, what do you think your cut height is off the material with a nozzle, the nozzle tip to material surface?
It's a 1/16 of an inch.
16.
So it's really
okay.
Like,
yeah, that's getting down there.
Yeah. So I'm
wait,
right
what is that? What is that in
0.0625?
0.065. Oh yeah. No, we're able to we cut most of our stuff at 50 thou.
So you're a little and mine's all just kind of
right, but if our material has any bow in it, we end up dragging, and so that's where we want to get a torch height control as well.
Yeah, and the interesting thing with these torch height controls are, basically the height is just controlled by a potentiometer height.
Right.
And so you can't really dial in, a number per se. It's literally like I let it go and basically touch the material and then just turn it up a little bit because it starts to, say a collision up.
Yeah. How does it what does it work? How fast is the transient response on the torch height control?
I mean, it's as fast as you have your settings on your in your motor control. Like I've actually turned mine down because it was pulsating a lot.
Yeah.
And then I could tell that was affecting the cut quality.
Oh, sure.
Because your focus was going.
So it goes in and out.
I have that turned down, the motor reaction turned down quite a bit, so it smooths that out, so it doesn't react, quickly to things.
What about when you're cutting parts that are close together and the capacitance changes because you've traversed over an area that you've cut out a part and there's no metal there left?
That's where this comes in. Like I can go, 1/8 of an inch, and it will follow it from an empty part.
Yeah.
Like you got a piece of scrap. Yeah. And I can butt something up, almost kind of the way you do for plasma, where if you're going to manually nest something together, I haven't changed any of that sort of idea of like putting something right there in a hole.
So you can cut like a bunch of rectangles out as long as they're 1/8 of an inch apart.
Yeah.
Okay.
And now if it's the same, if it's all on this a clean sheet, and those parts don't move, because I've noticed that with laser cutting, because the curve's so small, you don't have too many tip ups with thicker material. I know thinner, it doesn't matter.
Right.
But you could use common lines then too. So.
I haven't done that.
Yeah.
I don't have the confidence to do common lines.
I've done some stupid stuff. So, but
I've gotten really close.
Conversation.
I've gotten really close. I'll do, I don't know, a whisper. There'll be a whisper of a piece of metal left, but I haven't done any common lines.
Yeah, like here, let me see if I can. I think on this video, let me see if I have it.
Primarily because the common line, the laser will blast down through to the bottom of my table and hit my little protective surface on the bottom and bow it up even more than it already is. I have a piece of sheet steel on the bottom of my plasma table that started out flat and it's no longer flat.
I have a piece of stainless steel behind mine, so I understand.
Yeah.
But like here, right here, let me see here. Let me share. Can I share my screen?
Of course.
Yep.
Sure.
So y'all see that right here?
Yep.
All right, let me play that just real quick.
Mm-hmm.
So you can see that like I'm on the edge of that plate. See how close I was to the other one?
Yeah.
Let me see if I can zoom in. No, it's not letting me. So, I mean, you can see right there, it's about, even maybe less, 1/16 of an inch.
Mm-hmm.
And I'm cutting with that.
Okay.
So let me get off this.
I didn't know that there were THCs for arc torches. I mean, once I saw that, I was like, oh, let me see how this works. I mean, it was like within 5 seconds of you talking about what you bought, I was looking for those. Figure out how they work.
Kaya?
Oh, he might have closed the window that we were on. He'll probably join again.
Yeah.
Yeah. So just to I'll just say on my system, it works a little differently than Kyle's. Kyle's is mostly Kyle's integrates in with you using Mach 3 or using Mach 3 controller.
Yes.
Yeah. So the Crossfire has its torch height control is looking for an analog voltage that is proportional to the torch voltage, and they're running they just have a A to D running with a maximum of 3.3 volts. So they're expecting a voltage. They turn the torch on and they start to move and they average out about, I don't know, 200 or 300 voltage readings, and they lock in at that voltage level. And then when the torch goes up, the voltage goes down. The torch goes down, the voltage goes up, or the reverse. And they just follow along an analog voltage. So your approach has relay outputs for up and down. It won't interface directly in with the Crossfire design, but I could take what you're doing and create a little analog circuit that reads those voltages in from the relay outputs that you got, and then generate an analog voltage from that, which would equivalently work the same way, and then I wouldn't have to modify the torch height control on my plasma table.
Yeah, I mean, have you actually opened up like a control box and seen what's inside that control box?
What they use?
Yeah.
Yeah, I could tell you a great detail what they use. They have they're using a Gerbil board for their motion control system.
Okay.
And then they're using an Arduino Mini as their torch height control system. And
how are they interfacing between?
They're both of those boards make a USB connection into the application that runs on the Windows machine. And so they're just streaming out the analog voltage out of the torch height control system as a USB serial connection. And when they see that, when they set a value from the stream when it starts up, and then they basically send Z commands out every once in a while to correct for the height control. They do it in the control software on the PC. They don't do it in hardware.
What do they use as control software? Linux or?
No, they wrote a Java application, and it just runs full screen in Windows.
Oh, okay. So you
Yeah.
can't create like another profile with other settings or anything like that.
No. That's the unfortunate thing. But what I can do, because what do we use for the other lasers in the shop? Light burn. We could use light burn on our plasma table, and I might be able to come up with some module that interfaces in and just move over to running light burn, because we have 3 other lasers in the shop that use light burn. And
So
if we could migrate to using light burn on this, then anyone that's trained on any of the lasers can use any of the laser. You can use this as well.
So from that breakout board or the Gerbil, does it have, I guess, outputs to go to like the actual motor controllers?
Yeah. Yeah.
So
Gerbil,
the neat thing.
yeah, the
Go ahead.
Gerbil, they just run they run signals right over to 3 motor drivers, and then
Okay.
for X, Y, and Z, they have two Y motors, so they just parallel those ones.
And are they just simple 5-volt wires?
Yeah, they're just straight step and direction control.
So with the torch height control I used, it had 2 options. You could either do the just up and down signals,
Yeah, right.
or it actually had a splice where you can splice into that Z motor, and then that controls controls the Z motor.
Oh, that'd be great.
Yeah. So that
Do you have a way?
has some options.
Do you have a way to? Do you have a way to enable the torch height control at some point after you started moving?
I can, because I use the up and down, but
Right.
if you use the motors, I don't know how you would, because that's basically it's putting itself in between the motor control for the Z and things of that nature.
Right, because the way that this system works is it moves down in Z, and there's a limit switch on the Z platform. So when the actual mechanical mechanism on Z is loosely coupled to the lead screw. So they drive the whole thing down, and when it touches the metal, it disconnects that switch, and that's how they know where Z0 is. And then they pull up a little bit. So we'd have to still have that capability. And when it pulls up a little bit, then we want to basically turn on your torch height control that will send signals over to the Z motor driver and do all the control at that point.
So the way I would do it, do you have an option of not using the torch height control when you're cutting?
We can turn off our torch height control.
All right. So what I would do is, if you put that torch height control in between the motor driver, it's still going to let the signals come from the computer.
Yeah.
But like for mine, I mean, it's going to work the same way. Like, I wrote my post where it doesn't write any Z heights.
Yeah, we can disable that in the post.
Yeah. So then basically at that point, it's not going down to such sensitive material, because the capacitance is always working. So when you're jogging the machine over, it's always going to adjust up or down to what the machine is.
Yeah, I
so
understand.
basically what I would do is just write the post or run the machine like you're not using torch height control.
Yeah.
And then have that torch height control basically control the motor
all the time.
And the only downside to that would be your DRO for the Z probably wouldn't be accurate at that point.
Yeah.
Because it's sending signals directly to the motor controller.
Yeah, that's not important to us. That's fine. Right. I don't care about that.
So, that's an option for that.
Yeah, that would be good.
Okay. I love your conversation. And even though I cannot catch every single word of what you say, I think it will be very beneficial for our audience. And actually, I did another question for Kyle. and then I have a question for both of you. Is that okay? It's about the active cutting gas pressure control. It is, I think, it is also a point that can be upgraded for current project. Yes.
So
have you
really, I
ever?
think.
Mhm.
Go ahead. I mean, go ahead.
Yeah, you go ahead. You go ahead.
So, like, I guess the next step that I would take with this, if I wanted to like focus on probably better cut quality and such with
Mhm.
the system I have, is I would try
Mhm.
to find out or figure out how to basically get a proper cutting head and mount a proper cutting head to the table.
Mhm.
And somebody's told me that these exist. I have yet to
Yeah,
find them.
exact. It is already exist. I'm not sure whether you and Craig have noticed that there is already some machines presented just like your project. They mount the laser welder on the bed, which is designed by themselves, and they say that it is a all-round machine. They can
Right.
weld when you want to weld. They can cut when you want to cut, and of course, and cleaning and welding. Yes, and the questions I asked Kaya just now about the active gas control, about the multi-stage appearance, and the dynamic laser power control, and THC height control issues, they already fixed it. I think only need one controller system, whatever. You can fix all these problems. Yes. So I think because I will not name the company name in this podcast, but we know that, and actually I think
Well, let me ask you
we
this.
can.
I
Okay.
was more going on. Do y'all have or know that of any fiber, the QBH, the QB, is that the QBH? Am I referring to that the QBX,
Yeah, I know
fittings for the
KBH.
fiber? Is there a splitter that you can split the laser from the actual source to two different directions? Somebody's told me that they exist. Like it's a manual or electronic where it flips a mirror where you can go, from the source and either go down one fiber lane or fiber optic, cord or the other fiber optic cord.
No, I'd be all over that. I'd buy that right now.
Because then, if
Oh,
that
okay.
exists, then I could basically mount a proper. What I mean by proper, like an actual like fiber laser head onto the
Okay.
table. Because with
Okay.
like gas control and everything, that's where your dual nozzles and things of that nature would come in play. And like the handheld laser or handheld guns, just you only have a single, single, basically gas source. And so like when you're using oxygen or something, you want to be able to, have an assist gas, low pressure oxygen, to help the cutting.
I think
But
it needs a solenoid valve, according to Bruce said.
Oh yeah, you'd manifold up there. You'd manifold up all your source
right,
gases.
right. But I'm talking about like the start to that. So I'm not having to like change over the fiber optic because that can get iffy in a dusty environment. But
Yeah.
if I could have it where I have a fiber optic cable to the table and then a fiber optic cable to my hand laser,
Okay.
there's
Yeah.
some mechanism that uses the one laser supply that I could switch left and right to.
Okay. I
I mean,
understand. That's a good. That was a good
that's something
approach.
that
I would.
exists. Somebody
Yeah.
told me that
I'm
exists.
not sure. I would ask Andy to source about it. Yeah, that was a good approach.
I suspect
Yes.
that switch is probably
Okay.
going to be more that switcher probably more that expensive than just another fiber source.
Probably. Yeah.
I don't know.
And
because this is what we were thinking along the same lines, because we bought a BM 110
okay,
fiber
yeah.
head, real fiber head, and
Mhm.
we didn't know if we wanted to have a 100% dedicated laser cutter, or we wanted to have a laser welder. And that was, we really fell in love with the welding portion of it, but we were missing out
Okay.
on the cutting part. That's why we went down the road of just seeing if this would work. I mean, we figured out if this was going to work in a couple of hours because I actually had all the right connectors already. So I just looked at
Okay.
the manual and I cross-wired everything, and we were giggling at how easy it was for us to connect them together and what we were getting out for literally no cost at all to us.
I understand. So so for your routine work, you probably do welding more, right?
We do both, you know.
Okay.
My projects involve everything along those lines.
Yeah. Okay. So one question for both of you. So, if
Oh,
there's a
let me say one thing though.
okay,
Let me say about this gas,
okay.
your gas question.
Okay.
The limitation on my Skyfire Blazer, the
Mm-hmm.
internal gas valve is a low pressure gas valve. It won't work above about 250 psi.
Mm-hmm.
It will not open if you have gas higher than that. Okay.
Oh,
Um,
okay.
the SUP 23T head has a maximum uh, pressure going through it at 225 psi. So you can't really get up to where we really like to go. We'd like to get up to 300, but we can't generate that in air. Now I contacted. We have a local fab shop here that has a 12,000 watt fiber laser, and they only run compressed air, but they can run it at 300 psi. They started using nitrogen, but then they just switched to compressed air, and they bought a high psi air compressor, and they get really beautiful cuts out of that. And so
Right.
if we could run at that higher pressure, we would do that. But for what we do, for the amount of work that we do, we live with the dross and live with what we have, and it works fine for our workflow.
Okay. So you both are already technicians at this aspect. So you owning these some small devices or units, you can overcome the problems you have facing now. So,
Yeah, the quality of the cuts far outweighs the amount of rework of the cuts to get the dross off. What is minor compared to the quality and the accuracy that I'm able to get out of my cuts. And like Kyle said, our fit ups are excellent, which is what we need for the laser to laser weld. So the combination of the two, we end up using more floppy disks basically to clean up.
I went and bought a big old belt sander to deal with.
Perfect, even better.
Yeah, big old, one of those big, time savers just to feed the parts through, and that makes then you don't worry about the dross after that.
So you want a QHB splitter to split the fiber cables for dual use, and Craig, the suggestion is to improve the pressure of our blazer machine, and I think Emily has already written down, and after this podcast, I will send you both of you the emails about the solutions related to your project. Yes. And and we actually are developing our consumable grade small laser cutting machine, and that machine is specially designed for you guys, like workshop makers. I can share you some. I think Craig has already seen that, right?
You talking about the mobile one?
Mm,
No, go ahead. Go ahead and
no.
share it. Go ahead and share it.
Okay, my screen is off. Jay，你看一下我们的那个画面好像停了，是什么原因？Okay, I'll share you.
So I found a 1064 nanometer optical fiber splitter box from QHB on
Okay.
AliExpress, and it's $4,600.
Oh, really?
Yeah, but that's just me looking for 30 seconds.
Right.
It's meant, yeah, it's specifically got the connectors on there to go to Rakis and IPC Max welding machines. So it might actually be an option.
Because the way I looked at it, from the reason I bought the welder instead, because I always thought of building a table for laser, right? Just a laser based table, buying all the components. But I saw that. That's really neat looking. I saw the TikToks and whatnot that y'all have seen, and when I saw the person cut a shovel, I think it was a shovel that's in my mind with the handheld laser, and I was like, wait a minute, now these can do all of that, and that's why I went down the laser welder way, because I was like, man, this can do it all. And it's nice to have the laser source, the compressor, the chiller all in one unit. And with there's a lot of people that don't have the space for all that stuff. And if you can have one unit and serve two purposes, I think that would be beneficial, because I think people really love multi-use tools. That's why Leatherman was so well.
There are already some machines can be multi-use using yeah. You can. I will send you after this podcast. And the screen I'm sharing right now is the small laser cutting machine that can cut both metals and non-metals. For non-metals cutting, we use
I did see this.
Yeah,
I did watch this. Yeah, this is great.
Yeah, yes, and also we specially designed a compressor for this machine. That is, let me show you. Okay.
So this is a step up from a desktop machine, right? This is, how tall are these things? These are
It's
5 feet tall or something.
For height, I think is under 2 meters.
Yeah, right.
Yeah,
it's like the size. It's like the size of
the size. We have two options. One is 1 + 1 feet squares and 2 + 2 feet squares.
Okay.
And now is 2 + 2.
Okay.
And you're saying that for the metal you're using fiber, and then for the non-metals you're using
for
CO2?
normal we call it the blue laser.
Oh, diode laser.
Yeah, diode laser. Yes, exactly. I'm gonna show you something.
And this handles all the vacuum system. You have air cleaning, air quality. You blow this through a cleaner, or do you have exit gassing? Or how do you keep the gases from accumulating inside of this?
I will not take too many times to demonstrate what this machine is. I just so of course today's main topic is not about this. I just share a little bit, but what I can say is that we will make this machine modularly. What it mean? It means we designed the electrical parts modularly and the gas control parts modularly, and even the upper part and the lower part divided by the orange line, we
Yep.
can, yeah, separate, and customers can buy it and can amount them up, assembling them up by themselves very quickly. Yes, and plug and play. And we already tested. It has the very high acceleration and precision, and good cutting quality. And yeah, I will show you this one.
There's definitely a
Because
market
we,
for that. There's definitely a market for this product.
I think because this is air cooling machine, so we have this cutting air cooling one, and also we have laser marking machine air cooling one, and the laser welder machine air cooling one. We call it a air cooling family, and we will put all of them together in a workshop that we are building right now. We want to create visualized using application scenario for other people. Yeah.
Okay.
Hold on. And I think this is
Is the laser marking, is it a Galvo motion system, or is it XY or Core XY, or I see.
this is
Nice.
the special designed air compressor for that machine. I adjusted.
Oh, okay.
Yeah. So it has very high pressure,
Right.
and yeah. Yep, that's it. So when this machine comes out, I will send you guys the first information, and we plan to shift this machine to the US as a demo machine, probably to Chicago, to LA.
Yep.
And yeah, you know, Travis is in Chicago, right? And we have another partner in LA, so we want people to try that
Sure.
machine.
Sure.
Okay, okay, let's go back to the project, what you present. So if there's one thing that you want to to deliver to the people who want to try to replicate your project, is there and one thing that don't do that, the tips?
Yeah, I have a good tip. Don't try to cut rusty metal.
Rusty okay.
Yeah,
So
don't try cutting rusty metal, because almost 100% of laser energy does not penetrate the metal, and it bounces around a lot inside your shop.
Oh, okay.
And that
Okay.
is these lasers are inherently dangerous. And if you get that, you see the sparks flying off. Those sparks are driven by laser energy. You may not be very they might be very intense, but they go everywhere. So if you're
Okay.
going to be cutting something, and you just want to cut through some rusty stuff, don't even bother doing it. It's dangerous, and your cut quality will be horrible.
Okay. Okay. Good safety tips. What about Kyle's?
Yeah, I mean, on the
Or
safety. Go ahead. I mean, on safety, yeah, I definitely try to be very conscious of wearing the glasses. You know, even when it's cutting, don't look at it, because it's not a properly designed machine where you have a cabinet around it. You don't have the proper laser shielding around it, so bystanders. I don't have anybody in my shop when I'm using this, so it's you are taking some risk, and you need to make sure that that laser light, you can't see it in your naked eye. And I notice when I film it, the camera will pick it up, and it's almost like a purple light, but you don't see it with your naked eye, and you have to be just really careful. Wear your safety glasses. And then the other tip I would be is just find somebody that has good customer support. Like when I bought my machine, it's they answered my questions and everything. They were good, but you want to make sure you buy something from somebody that's going to be able to answer your questions, because with this laser technology, it's new to us. And I don't think there's a lot
Mhm.
of people in the metal fabrication business over here in the States that have dealt with this. And so, find someone that's willing to answer questions and ask questions. Ask a lot of questions before you just assume. I want to assume anything,
Right.
because these can be dangerous.
Yes, let's keep in
But
touch because I think you both are good person and qualified person to do that job. Technical
well,
questions about
yeah,
lasers. Yes, yeah.
that's the reason why I went with Skyfire.
Mhm.
I could have bought one right off of Amazon. All right,
Okay. Yeah. Sure.
roughly the same price,
Mm-hmm.
same kind of functionality.
Mm-hmm.
Um, but I didn't know anything about these things. I mean, all I
Mm-hmm.
have is YouTube videos, and
Mm-hmm.
those, it's whether or not. But then, when Travis Mitchell came out with his series,
Mm-hmm.
and he was working on his second machine, he said, I've
Mm-hmm.
been using stuff from Skyfire, and
Mm-hmm.
he gave a vote of confidence to use you guys, and so I just
Yeah.
contacted and started a conversation. I I get very fast technical support from Skyfire, and
Yeah.
and
Thank you. Thank you. And a shout out to Travis. He's a
oh yeah,
yeah, great
he's
person. Uh,
he's doing
And
interesting projects for you guys, and he was a good
yeah,
choice.
yeah.
He was a good
He
choice for
always
you for your ambassador.
yeah, she always exploring the things that no one has ever done in the market.
Oh
And
yeah,
yeah, I also want to go back to Kaya. Kaya, this is the first time so we get connected with each other. But I have followed your YouTube account for many time for I think for 3 or 4 months. You
Well,
did very good hardcore content. But well, if I could give you your suggestion that you can, yeah, you can devote more efforts on the videos, editings, and something like that. Yes, yeah, your
so
content is great. Yeah, yeah.
you want more videos? Is that what you're saying?
No, no more videos. I would say, uh, uh maybe after this podcast, I can give you some suggestion,
I'm,
skills to
I'm
improve your YouTube account. Yes.
Yeah, please do, because
Yeah.
it literally is just something I kind of do on the side, and
Mm-hmm.
I do it for fun. And yeah,
Yeah.
I'll take
Okay.
these. Yeah.
That's all my questions, and I feel very honored to discussing with you, credible technicians. So, and as one of the members of Skyfire, I would like to say our mission is not only sell the products and make profit. We want to connect it to the peoples in the circles, and we create together the community. So that's my at least my how to say, I don't know. I cannot come out with English right now.
I
So
understand. Yeah.
yeah, yeah.
no, it's
Okay.
fine. You're
Mm-hmm.
making a concentrated effort in supporting the DIY community, and I
Mm-hmm.
believe that you're probably the only company that I've seen actually doing
Mm-hmm.
that.
Yeah. Thank
The
you,
fact
thank you. And
you have this podcast, you're running these competitions,
mm-hmm.
your active support, you have a U.S.
Mm-hmm.
ambassador with
Mm-hmm.
Travis and also Tamar,
Mm-hmm.
um, and so you're
And
working your
and
way
you,
there.
I think
Oh
you're
yeah,
both,
and
both are
us
the
too as
ambassadors.
well.
Yes. Uh-huh.
Sure, sure.
Mm-hmm.
No,
And
I like posting the videos. I
okay.
don't get, of course, I don't get to the shop enough or as much as I want to, but I'll continue to post things as I make various
Yeah.
projects.
Yeah. And I think Emily will contact you after this podcast to give you
Okay,
some, like I just said, the consumables and the and some um, how to say that the collaboration plan that we may connect with each other. Yes.
okay.
Okay, that's for today. I think it's what time is it now at your side?
We've been on the air for an hour and 10 minutes.
Oh, okay. So that's it. It's nice to talk with you,
Okay,
and
Thank you.
I have to say bye bye.
yeah. Have a good day.
Okay,
Bye.
have a good night.
Bye. Bye.
Bye
Bye.
bye. 嗯哼。啊，怎么？你说什么？我刚刚说了，等一下，我先说完我的，你再说啊。就第一个就是我跟他们这个讲完了之后，就是我们 K-Rigg 和 Kyle， 我们也可以，你后续我们可以跟他合作一下，就是看有没有合作可能啊。这是这个是我比较喜欢的。另外就是那个Welder送给他们。这就是建立联系嘛，因为我们另外一点就是对，我这还没有。